Alright, another video. So, this one today we're focusing on the science revision for the test coming up. So we're looking at energy and different forms and how it's transferred and transformed. Just getting a better understanding of what's coming up for the test. So I'll just go through this revision sheet which is on DayMat. But I'll just go through a couple of things, explaining them to make sure that we have that understanding. The first thing is we want to understand that there are lots of different forms of energy. We should be able to list them, but mainly understanding the difference between potential energy and energy in action. So potential energy, that's like energy which is waiting to happen, waiting to perform basically. It's sitting backstage, it's waiting to get out there. So that's things like gravitational potential, elastic potential, chemical, and even nuclear. They're different forms of potential energy. But then we have energy which is actually occurring. So heat, heat is occurring, light, sound, kinetic, electrical, and just understanding the difference between those. So especially also understanding that the energy which is waiting to happen, so say, for example, gravitational potential, all of a sudden, when something happens, that can turn into, say, kinetic energy. Understanding how the energy changes. So that's also understanding the difference between energy being transferred and energy being transformed. So energy being transferred through an object, that's basically it's the same form of energy, it's just passed along. So when I'm playing golf, I swing a golf club, the kinetic energy from the golf club gets transferred into the golf ball. So we still have kinetic energy, it's just moving from the golf club to the golf ball. Now that's different to energy transforming. That's from energy changing. So for example, if you were, let's say watching TV, you have the electrical energy going through the TV, then that transforms into light and heat. So that's still, the energy is flowing along a chain, but it's changing forms. So that means it is transformed. Now we need to understand this energy efficiency. Now energy efficiency, that's a percentage. So that's why we divide however much good energy we get out, so that's the energy we want, divided by the energy we put in, times by 100. So the higher something is, the higher that percent, the more energy efficient something is. So if you have 100%, it is perfectly energy efficient. But that doesn't really happen. Generally, we're looking more at that 30 to 50% range. Now, what in food provides us with energy? Now, it's been a while since we've done food, but that's the chemical energy of food. So once it goes into our body, it's got that potential. And it's actually the macronutrients, so the proteins, the carbohydrates, and the fats in our food which allows us to utilize energy. Now, can you remember what it's measured in? It was in joules, wasn't it? Joules or kilojoules. Joules. Spoke about that question 2A before, but with a golf ball. So once again, if we're hitting a cricket ball, we're swinging the bat with kinetic energy, we hit the ball, so that means we are transferring the energy across, transferring the kinetic energy from the bat to the ball. So question 5 will be a really useful one for you. Okay, I can almost assure you there's going to be a question like this in the test. So understanding that, for example, fridge A working out the energy efficiency and fridge B working out the energy efficiency, then from that being able to discuss which one is more energy efficient for a household. It's not necessarily the one which gives the most energy, it's which one utilizes the most energy. So the higher percentage. So that means what would have a higher energy star rating? You know on appliances how it has those energy stars? The higher the star is, the more energy efficient it is. and understanding the wasted energy. So what do you reckon? What sort of wasted energy would it be? Yeah, it's probably that heat, and maybe heat, and what is this for a fridge? Sound, um, different forms of wasted energy. We don't lose the energy; it's just wasted because we don't use it for our product. So the little bit of work we're doing at the moment about what advice we'd give to the school, same thing we can use at home for the different rooms and air conditioners to be more energy efficient. Alright, I hope that helped, and that we're ready for the test coming up.